Hey everyone, my name is Anvita Bansal and we are back with another lecture based on stacks and queues. So let me just quickly check if we are live. Yes, I think we are. Fine, let us start off with the question. So today we will be discussing this problem from stacks and queues, which is your queue using two stacks. Where is it? So this is your problem. Yesterday we discussed this question. I hope you all tried it on your own. This is a good question. So queue using two stacks is also an easy problem. It's an easy one. Let us have a look what to do in this question. Okay, so what does this problem mean is that you have to implement a queue using two stacks S1 and S2, which means that you know the operations of queue, right? You know the operations of stacks. You want to implement the operations of queue using two stacks. Okay, so let's have a look what we want in this question. I'll tell you using the example. Okay, so let's see. I'm taking the first test case which we have here. Okay, then moving ahead. Your question says that you have to implement what? You have to implement queue, okay, using stacks, which means what are the operations of queue? First of all, what operations do you perform in queue? You push into your queue, you pop from your queue, you get the top element from your queue. But this problem is even easier because you only have to implement two operations of queue, that is, one is push and one is pop. So push they have given with NQ, you have to perform NQ operation, QUE, and other one is DQ operation. Okay, so if I talk about a queue, literally a queue, how does the operations in queue look like? How do the operations look like? I am enqueuing. The example that I can see here is, let us see, NQ2. Let's say NQ2, NQ3, NQ2, NQ3, then we have DQ, then we have NQ4, okay, then we have DQ. Now what is the output that you will get? So when I push 2 into my queue, I will push it here. Okay, when I NQ3, I'll get 3 here in my queue. This is your queue. When I do a DQ operation, so the element that was pushed into the queue at the very first position, that is in the front of the queue, right? So it follows first in, first out. The element which was first inserted into the queue should be removed now when I am calling DQ operation. So this element will be removed from the queue. So now your queue contains only 3. Now let's perform another operation, which is NQ4. 4 will be pushed here. Now I'm calling DQ. So your 3 will be removed from the top of your stack, right? So what elements got removed? 2 and 3. Fine. Okay, now what is, do we have any other operation? No, there are no other operations. And your question says, what do you have to return in your question? So you have a query queue of 2 types. First means you are pushing. Second means you are popping, okay, from the queue, and you are printing the element that you are popping. If there is no element, return -1. So in the output, you are actually returning the elements in the same order as they are removed from the queue. So whenever we are performing DQ operations, we are getting some elements. Here we got 2 and 3. So this is what you have to return. So basically you just have to return nothing else. Okay, return what? Return the DQ'd element. So this typically I typically explained you how operations in queue take place. True? Fine. Now the question is, if simply I know I can use simple, I can implement a queue, but in Java, means in any language, we can implement obviously from scratch, but we don't need here. I can create a queue of a type linked list maybe, and then use operations like queue.remove, queue.add, right? So a queue will be implemented. So there are lots of ways in which you can implement a particular data structure. Now the demand of the question is not to implement queue using two stacks. Okay, now how do we implement a queue using two stacks? That is the problem here. So I'm sure I don't have to give too much of attention on how stacks operation take place. If I have to do push 1, push 1, push 2, push 3, then I say pop, I say pop again, I say push 4, I say pop again. So what will you get into your stack? Just I'm showing how operations in stack will look like. When I'm pushing 1, 1 will go into stack, 2 will get into stack, 3 will get into stack. Now I am saying pop. So pop will remove the last input element, last in first out. The element that I just pushed into my stack will be removed. On the contrary, in the queue, the element which was very first pushed into my queue got removed. That is the difference between these two. Queue follows first in first out and stack follows last in first out. Now when I say pop again, so this 3 will be printed, after which 2 will be printed, because these two elements got removed using this pop operation. Then I am inserting 4 into my stack, so it will look like this, 1 4, and then I'm doing pop again, so 4 will be removed from my stack, and this is how my popped elements will look like. Okay, I hope queue and stacks are clear, how the operations of push and pop take place in both the data structures. Now coming on to implementing queue using two stacks, how this thing can be performed. That is our target. See, very simple thing is I can take two stacks, right, S1 and S2. So in your question you are already given two stacks, already implement, means two stacks are already defined in your code as input and output. One stack, okay, S1 and S2, I think that's fine. Then queue using, we're doing this question, right? Okay, so this is S1, other one is S2, and you have to perform push and pop operations. Am I doing this question right? Yes. Okay, fine. So now what? You have to actually implement a queue. That means you have to implement push operation and pop operation. Fine. Now let's say I want to push 1. So you push that element into stack 1. Now you want to push 2. So you push this element into your stack 2. Now I say push 3. So you push element into stack 1 again. Now I say pop. So just remember, we are doing it in stacks, but we have to perform operations as if we are implementing a queue. So now when I say pop, which element ideally should be removed from this whatever things I have pushed? If it were ideally a queue, the elements got pushed like this, 1 2 then 3, and now I'm calling pop, so 1 should be removed. The element that should be removed should be 1. Now if you have a look at your S1, you will see that the elements, if I do S1 dot pop, the element that will come out of stack 1 will be 3. So I think this is not the right thing that I'm doing. I'm not getting the right element that should be popped if I am implementing a queue. So let's do one thing. One thing that can be done is that as in when I'm pushing into my stack, okay, simultaneously I push the elements into my stack 2. What do I mean by this? You pushed element 1 in your S1. Now you do what? All the elements that are present in stack 1, you move them to S2, right? So now you have 1 in your S2 and this is empty. Now you push 2, okay, or not even like this, you can, I think, okay, fine, yeah. Now you have 2 in S1, right? You have 2 in S1. You move all the elements from S1 to S2 again. Now you have 2 here. Now you push 3. You push 3 into S1. From S1, you push it back to S2, right? So what are we doing basically? As in when we are getting any element from S1, either you do this thing, you push them all at once, 1 2 3, and then the next element that you have, if you want to push it, you have to push all the elements back into this. So I don't think, one second, wait, I think one thing is not right here. Wait, before moving ahead, let me do, there are two ways. There are two operations that I want to implement. One is push, other one is pop. One of them, any one of them I can choose to be a costly operation. In general, when I do push into my stack, it is O1. When I do pop in my stack, that is also O1. But since I want to implement Q, let's try implementing a queue by making any one of these costly. So what I am going to do here is that, let's say the way that I'm going to implement here is I'm pushing 1 in my S1, right? I push 1 into my S1. Now next thing is what? I'm pushing 2 in my S1. Next thing is I'm pushing 3 in my S1, right? Simple. Now when I call for a pop operation, I ask, this is my second stack. Is this empty? Yes, it is empty. Then if it is empty, what you should do, that you will remove the elements from stack 1 to stack 2 until S1 becomes empty. Why? The reason is, see, we were doing push in O1 of time complexity because we just started from this element, kept on pushing into stack 1. But now we want to pop. If I do pop on S1 itself, then the element that will be popped will not be 1, which we want if it was a queue, right? So let's do one thing. Until your stack becomes empty, you push all the elements from S1 to S2. So one by one, when you do this, you get 3 here, you get 2 here, you get 1 here. Now in this stack, you have the element at the top of S2 which you actually want to remove, because we are trying to get the element in the order of a queue to come at the top of S2, so that when I do a pop operation, I can get this element in O1 of time. But actually, in order to perform this operation also, I removed all the elements from S1 to S2, so that took O(n) of time complexity, and now I can do S2 dot pop. So S2 will give me the element that I actually want to remove. So 1 will be removed. Now you have 1 with yourself. Okay, so this will return you 1. Now let's say we do push again. Push 4. So when I am pushing 4, I do not do any check. Right now your S1 is empty. Pushing is always happening is S1. Only thing is, whenever you get a pop operation, you go ahead and check, is S2 empty. If your S2 is empty, then you should move all the elements from S1 to S2, so that I can get the element at the top of the stack, which actually should be removed from my queue. Right now, when you ask your S2, is it empty? No, it is not. So when you perform, if I say the next operation is pop, so which element should be removed? You pushed 2, then you pushed 3, then you did pop, so 1 was removed. Now you have pushed 4, so now again you are doing pop. So actually this element should be removed. What do I have on the top of S2? 2 only. So 2 will be removed. You got an answer 2 here, and 2 got removed. Now let's say I say pop again. Now this time pop should give you 3. So what is present at the top of S2? It is 3 only. So 3 got removed. Let's say I again say pop. Now what do you have in S2? Your S2 is empty. So you will check, if S2 is empty, you will check while your S1 is not empty. If S1 is not empty, that means there is still some element present that can be removed from your queue. So we got one element, so you move this element from here to here. You're trying to understand what we are doing. Now when I got 4 and I do S2 dot pop, I get 4 from here. S1 is empty right now. Now if I say pop again, you will see S2 is also empty and S1 is also empty. So nothing will be, means either you will return -1, that's what you will do. Or if I say push now, push 5. So where will you push this 5? This push will happen in S1 only. So now let me write a pseudo code. What we actually did here is, let me just check if you guys are able to. If S2, so Abhinav has a doubt, if S2 empty, then push S1 elements. Right. See, when you have to understand this thing, let me just write here. When are we doing these things? So you have 2 stacks, S1, S2, right? I'm pushing elements directly into S1. Let's say 1, 2, 3. When we have to, this is your push operation. Whenever you are calling your push operation with some integer x, you simply do S1 dot push x. Okay, fine. Now when I have to implement my DQ or pop operation, So pop operation does what? Whenever you have to pop some element, you know, if you pop from S1, so it will remove the element that is recently pushed, and Q does not want the element that is recently pushed, it wants the element that was first pushed into my data structure. So one should be removed. Now if you want to get one, first you will check. What are you going to check in this case? Is your S2 empty or not? Fine. If your S2 is not empty, first of all, if it is not empty, dot is empty. If it comes out to be not empty, then you directly return S2 dot pop. That means the topmost element of S2. But in this case, we can clearly see that your S2 is empty. So you come at the else case. That means you have some elements that you can push from S1, and the order in which they will be pushed into S2 now will have the element at the top of S2, which should be actually removed if it was a Q. Okay, so from my S1, I will now, in your else case, you do a while loop, which while loop says that while until your S1 becomes empty, S1 dot is empty. Okay, until your S1 becomes empty, do what you are pushing in S2, S2 dot push S1 dot pop, means the elements that you are removing from S1, push them into S2, right? And then you come out of this while loop, and still in your else part, then you return. Now you have pushed elements from S1 to S2. So how you pushed? 3 came here, 2 came here. So you are pushing until your S1 becomes empty. Now all the elements are in S2 in the order of a queue. First element that will be removed will be 1, second element will be 2, third element will be 3. And now then you return S2 dot pop. This is what you are doing in your pop operation. So do you see one thing, that we made pop operation costly here? Our push operation is taking O1 of time because we are pushing directly into S1 and doing nothing. And in pop operation also, it's not that every time it is taking On of time complexity. If S2 is not empty, for example, after pushing 1, 2, 3, my operations were push 1, push 2, push 3. Now I say pop 3 times, pop, pop, pop. Okay. So you will see, first I remove, now the condition is that I pushed 1, 2, 3, now I want pop, so I will go into else case, and while S1 is not empty, I removed all the elements from S1 to S2. And then what? While you did this thing for one time and it took you O(n) of time complexity. For this pop operation, you took O(n) of time complexity. Now 1 will be removed from the top of your stack. Now you are calling pop operation again. For this case, do you realize that you will, when you come at this else part, you will check, not else part, in if part of this pop operation, you will check S2 is not empty. So you will directly return the top element of S2. The top element is 2. So how much time this pop took? So this pop took only O(n) of time complexity. Let's talk about this pop. S2 is not empty. When you go to pop operation, it will check, is S2 empty? No. So if it is not empty, that means the element that is present at the top of it should be removed, and I will remove. So this pop also took O(n) of time complexity. So we actually minimize the time complexity. How did we minimize it? That we are actually taking O(n) of time complexity in only pop operation, that too not always. Okay. So this is how we have reduced the time complexity. Instead of if I would have made push operation costly, that means what I was doing, I was pushing the elements into my S1, S2, S1 one by one, and then after each push operation, I am actually shifting all the elements from S1 to S2, right? So that whenever I call pop operation, I get that in O(n) of time complexity. But my push operation in that case was become O(n), because every time I'm pushing, I'm also pushing it to S2. One got pushed here. Now if I call pop operation, I will call pop only on S2. Now let's say I made a call to push S2, push 2. So second element will be pushed in S1. Again, I move it to S2. So these things are happening when I'm making my NQ operation costly. Understood? So this is what we are going to do. This is how we reduced our time complexity. If you have any doubts, you guys can ask me. I'll wait for a moment and then we'll start coding this question. Okay, let me know if you guys have any doubts. This is what we have done here. Right? So the first case could be, means the first one method can be that we are pushing all the elements in S1. We are basically making NQ operation, push operation costly, in which what we are doing, while your S1 is not empty, you are pushing everything from S1 to S2. That's what you can do. This is one thing. So this is what we are doing, that all the elements from S1 are getting pushed to S2, and again now we have one element, so I'm pushing it into my S1. That's what we are doing. Okay, so for every push operation I am removing all the elements from S1. I'll just tell you also. For example, right now I am pushing 1, then I'll push 2, then I'll push 3. So this is my S1, this is my S2. This is the second approach, which is a costlier one, that is why I'm telling you this as well, so that you understand that how we optimized it. So this is one. You ask, while your S1 is not empty, right now it is empty, so you just push here. Now you have the other element, you want to push 2. Then you will ask, while S1 is not empty, so S1, until it becomes empty, you push all the elements from S1 to S2. So right now S2 will have 1 and S1 has been removed, and you push 2 here. Okay, now let's say I want to push 3. Fine. So what do I do? Now again I want to push 2, so all the elements from S1 will be moved to S2, so it will become like this, and then you have pushed 3 here, then you have pushed 3 in this. Also you are doing one more thing. When you are doing this, you are moving elements back from here to here. You getting this thing? 3, 2, 1. See, I'll tell you what is happening. If it was a queue, I'm pushing 1, I'm pushing 2, I'm pushing 3. So actually what I'm doing is, I'm just telling you this approach so that there are high chances that you might have thought about this as well. That is why I thought of discussing this too, because both are intuitive, but yeah, there are high chances that you might get this one. Okay, push 1, then 2, then 3. So I ask, this is S1, this is S2. S1 is right now empty. Then you push 1 here. Now you check S2 is empty or not. Yes, S2 is also empty. So you don't do anything and you go and push next element. When you push next element, you check S1 is not empty. So first of all, in order to push 2, you have to make S1 empty by pushing all the elements from S1 to S2. So you push 1 here, then you bring your actual element into your S1, that is 2. And the element which you just pushed into S2, that should be brought back to S1, so that you get like this, right? So that your top element is always maintained, which is actually the first element of your queue. Now you want to push 3. So you ask, S1 is not empty, so all the elements will be pushed to S1. Right now it is empty, so one by one, first 1 will be pushed, then 2 will be pushed. Now you push your original element, the element you want to push, into S1, so that 3 can be the element which is actually the element that I recently pushed, and the element that was very first pushed will remain at the top of your S1. Now move back the elements from S2 to S1. So bring 2 back, bring 1 back. So this is how your S1 looks like. So you are trying to understand, yeah, our push operation has become costly by ON, because every time I'm pushing a new element, first I'm checking while my S1 is not empty. S1 dot is empty, right? I am pushing all the elements from S1 to S2, that is S2 dot push S1. Then I am actually coming out of this while loop, and then you push your actual element into S1 dot push X, and then again the elements that you push to S2, move them back to S1, then move from S2 move it back to S1. That's what you are doing. So you are moving n elements, n minus 1 elements to S1 from S1 to S2. Then you are bringing them back when you have pushed that particular element. So this is typically taking O(n) of time complexity. Okay. So that is all about it. Let's go ahead and code our problem with the second approach. So now I hope you understood that how we optimized using this approach, that we were actually doing pop operation costly, that also at certain times. Okay, so I hope you understood. Let me see if you guys have any doubts. Okay, let's code it now. Cool. So let's make our, we have two stacks already, and I told you our push operation is going to be of O1 of time complexity, that is simply S1 dot push X. Okay, fine. Your pop operation will become costly, that too only at certain times. What is those certain times? You are checking while your, if first of all you check if your S2 is not empty, not S2 dot is empty. Okay, then what? You directly return the top of your S2, S2 dot pop. Cool. Okay, in the else case, as I told you, in the else case you move the elements from S1 to S2 and then remove the element that is present at the top of your S2. So while your S1 dot is empty, okay, move all the elements from S1 to S2. So S2 dot push S1 dot pop. Fine. Okay, now you come out of this while loop and you return S2 dot pop. That's all, and let's return it. So we have made pop operation costly of O(n) of time complexity. What is the mistake? There is some mistake. Let me check. If your S2 is not, while S1 is not empty, you're pushing this S1 dot pop. Where is the mistake? Fine. If S2 is not empty, return S2 dot pop. That is okay. Else, while S1 is not empty, S2 dot push S1 dot pop. Then you return S2 dot pop. What is the issue? O1 for push and O(n) for pop. I think that is fine. What is the error? If we have input, while no, this is fine only. Return S1 only we are pushing. If you guys find an error, let me know. Let's see what is the issue. Empty stack. Empty stack. Why? S2, while your S1 is not empty, we are doing S2 dot push S1 dot pop. I think that is fine. You guys found any issue? What is so complicated about it, Abhinav? Can I know? That is the approach that you have to use here. If you have any other, you can go ahead with that. This is actually a very easy thing. There is nothing complicated about it. Let me know if you have another sorted approach. Let me check why this is giving us error, which it actually should not. I think I have submitted previously. We did the same thing, right? Here I think I made the push. Let it be. Two stacks. S1 S2, if S2 is not empty, it is okay. It should not be giving any error. Return S2 dot pop. Why your S1 is not empty? I think you need two stacks. This is the one that we are discussing, right? Let's submit it. See, it's working here. Both the questions, I don't know what is the issue. I'll just show you. This is void enqueue, right? This is void push. We are pushing s1 dot push x, only the variables different. Here we are doing input dot push x. Okay, now let's check about pop operation. So this is your pop operation. If your s2 is not empty, you are returning s2 dot pop, right? If output is not empty, here we are doing s2, right? S2 is equivalent to output. Here we are doing output dot pop. Okay, I'm just showing you that. I don't know why is it not working, but it's exactly the same thing. Otherwise we come in else case. While your s1 is not empty, you're moving elements into s2 from s1. Okay, so while s1 is not empty, you push elements into s2 from s1, and then you remove s2 dot pop. So I think there is some, maybe they are expecting the other way around, other approach, but yeah, that is about it. Okay, I'm just seeing s2, if s2 empty, pop s2 dot peak, else while s1 is not empty, return popped, s2 dot push, s2 dot push, s1 dot pop. Let's just check. I think you can try it on your own. I've told you both the approaches. Maybe you can try second approach in the first one in here. Maybe you can make the push operation costly and try to solve this problem. So that is all about it, guys. If still you have any doubts, you can ask me. Okay, we are done. Still I'll see why this didn't work. Let us check. Maybe I submitted some time back. Let's check it here. Here I have made push operation costly. I don't want to see this. Here also push operation is costly. So actually I think this problem maybe demands you to make push operation costly. So you can try it that way. That was all. So I'll just wrap the class up. If you guys have no doubts, Abhinav, is it clear to you now? Do you have any doubt in the solution? So they expected O1 for NQ, that is why this one worked. And here, let's see their expectation. You're required to complement which takes which returns an integer popped out from the queue -1 if the queue is empty. Let us return -1 also. We will see. It won't make a difference. The printing is done automatically. Okay. O1 for push. We are doing O1 for push, O1 for pop, or O1 for push and O1 for pop. Let's try it. I'm just checking this out. No. All clear. Good then, everyone. So I'll suggest you try this solution with the other method in which we made push operation costly. You remember, by ON. So do it that way. Now let's wrap the class up. See you all in the next lecture. Thank you, everyone. Bye bye.